Okay, so hello everyone. Thank you for attending this session. My name is Yoshiyuki Tabata, and I'm a senior OSS consultant at Hitachi. Today, I'd like to talk about mastering authorization, integrating authentication and authorization data in cloud-native apps. Authorization is difficult to implement, but necessary to implement. Until recently, authorization has been somewhat chaotic, but currently there is an initiative towards standardizing authorization. I will explain the activities of the initiative. Additionally, there are still some points that can be a pain for developers when implementing authorization. One of them is this, integrating authentication and authorization data. And I will explain this with 4 options, and at the end, I will show you a demo of it. So this is today's agenda. First, I explain what authorization is. Then I introduce an initiative toward the standardization of authorization called AuthZEN. After that, I will introduce how to integrate authentication and authorization data. Finally, I show you a demo using Keycloak and Toppers. First of all, let me introduce myself. My name is Yoshiyuki Tabata, and I'm a senior OSS consultant at Hitachi. Also, I'm a tech lead of CNCF Tag Security and Compliance, CNCF Ambassador, a Cloud Native Community Japan organizer, and a Cloud Native Security Japan founder. I mainly work as a specialist in identity and access management and API. Usually, I have consulted on designing API and authentication authorization platform for about a decade. And I'm also a community contributor. Currently, I'm contributing actively to CNCF Tag Security, and also I contribute to some important functions to OSS, such as Keycloak and IAM OSS. Regarding other activities, I have given talks at events and written some books and articles, and hosted some CNCF meetups in Japan. I'd like to introduce another person who is a solution collaborator of this session, Omri Gazit, a co-founder and CEO of Assalto. Also, he co-founded the AuthZEN initiative, which I will introduce later. And Omri and I discussed the approaches to integrating authentication and authorization data introduced here and compared each approach. So let's get back to the main topic. First, what is authorization? Authorization is different from authentication. While authentication is the process of verifying an entity's identity, authorization is the process of verifying that a requested action or service is approved for a specific entity. As shown in the figure below, when an entity requests a resource, authentication asks who or what does request the resource, whereas authorization asks, can the entity take some action regarding the resource? This is a difference, and it is important to remember that authentication and authorization are different. Next, authorization is ranked as one of the most important security risks. This is the OWASP top 10 API security risks. And as you can see, 3 authorization-related security risks ranked high: broken object level authorization, broken object property level authorization, and broken function level authorization. When considering security, I think you can see that authorization is not optional, but essential. Next, I introduce implementation difficulties surrounding authorization. In contrast to authentication, authorization implementers are challenged by the lack of established standards and the large number of good OSS implementation. The left side, regarding authentication, there are several standards that are often used, but on the right side, regarding authorization, there are no established standards for communicating authorization information. And there are good OSS implementations such as Open Policy Agent, OPA, Open FGA, Topaz, and so on. This situation makes authorization difficult to implement. The good news is that currently, the OpenID Foundation AuthZEN Working Group is working to develop standards to address this situation. Next, I introduce an initiative towards the standardization of authorization called AuthZEN. As I said before, authorization is recognized as the most important security risk, and there is a demand for dynamic and fine-grained authorization schemas. OIDF Authorization Exchange Working Group, that is AuthZEN Working Group, was established in 2023 and is developing standards for authorization. AuthZEN uses the P2P architecture to separate the authorization logic from the application logic and flexibly implement authorization requirements. I briefly explain the P2P architecture. There are components such as PAP, Policy Administration Point, and Policy Decision Point, PDP, Policy Information Point, PIP, and Policy Enforcement Point, PEP. When an entity requests the resource, PEP receives the request and delegates the authorization to PDP. PDP makes an authorization decision using authorization policy and the data, and sends the result of authorization decision to PEP. If the result is true, PDP proxies the original request to the resource. AuthZEN uses this P2P architecture and currently standardizes interfaces between PEP and PDP as the authorization API. I will introduce current AuthZEN's activities. On May 15th of this year, AuthZEN published Draft 04 of Authorization API 1.0, which specifies the following 5 APIs: Access Evaluation API, Access Evaluations API, Subject Search API, Resource Search API, and Action Search API. I will introduce each API on the next several slides. First, Access Evaluation API. This API defines the message exchange pattern between a PEP and a PDP for executing a single access evaluation. When delegating authorization, PEP sends the subject, resource, action, and context. The subject is the user or machine principal, and the resource is the target and access request. And the action is the type of access that the requester intends to perform. The context object is a set of attributes that represent environmental or contextual data about the request, such as time of day. In this example, PEP is asking if Alice can read the to-do resource, and it's providing the time as context. When sending an authorization decision, PDP just sends true or false. This is the Access Evaluation API. Next, Access Evaluations API. This API is similar to the one before, but this API executes multiple access evaluations. This API is useful for use cases such as operating multiple resources in a single access. When delegating authorization, PEP sends evaluations. This contains multiple access evaluation requests. In this example, PEP is asking if Alice can read boxscoring.md and subject-search.md and can edit resource-search.md. When sending an authorization decision, PDP sends true or false for all access evaluation requests. In this example, Alice can read boxscoring.md, but cannot read subject-search.md and cannot edit resource-search.md. This is the Access Evaluations API. Next, Subject Search API. This API is also similar to the ones before, but this API returns all of the subjects that match the search criteria. In this example, PDP is asking who can read account 1 to 3. Then PDP answers that Alice and Bob can read account 1 to 3. And this page key is used for pagination. So this is the Subject Search API. And the next one is Resource Search API. This API returns all of the resources that match the search criteria. In this example, PDP is asking what account resource Alice can read. Then PDP answers that Alice can read account 1 to 3 and account 4, 5, 6. This is a Resource Search API. The last one is the Action Search API. This API returns all of the actions that match the search criteria. In this example, PDP is asking what Alice can do for account 1 to 3. Then PDP answers that Alice can read and write the account 1 to 3. This is the Account Search API. Also, this draft 04 newly specifies policy decision point metadata for exposing PDP configuration. This is kind of sub metadata for OIDC OpenID Provider and OWASP authorization server. PDP returns API endpoints that PDP supports. This is the policy decision point metadata. In this way, the interface between PDP and PDP are gradually being established by OauthZEN. Next, I introduce one big consideration of authorization, how to integrate authentication and authorization data. So far, just the background and trends in authorization, and from now on, the main topic of this session. I introduce a challenge in implementing authorization practically. When implementing authorization practically, it is not enough to only consider the peer-to-peer architecture. It is very important to consider the relationship with the identity provider, IDP. Concretely speaking, attribute information such as users' groups and roles that are often used in authorization decision is typically managed by the IDP. So we need to consider how the PDP uses this information. As you can see from this figure, resources are requested with an auth access token. And this access token was issued by issued by the IDP, and is often used by PEP to identify the subject. Therefore, IDP and PDP are deeply related, and how to integrate authentication and authorization data becomes important. Next, I introduce how to integrate authentication and authorization data. There are 4 options. I will introduce each option on the next several slides. The first option is that the IDP puts data into the access token. When issuing an access token, the IDP inserts user attributes, for example, groups and roles, directly into the access token, such as JOT. Then, when delegating authorization, the PEP extracts and uses the access token's information. This option can simplify the system configuration, but it is difficult for fine-grained authorization, and it cannot be real-time authorization. Option 2 is that the PEP retrieves data before delegating authorization. Before delegating authorization, the PEP queries the IDP to retrieve user attributes then uses them for authorization of delegation. This option can be real-time authorization, but it places a high burden on PDP development and has high latency. Option 3 is that the PDP retrieves data before making an authorization decision. Before making an authorization decision, the PDP queries the IDP to retrieve user attributes, then uses them for the authorization decision. This option can lower the burden of PDP development and simplify the system configuration, but it has high latency and it raises the complexity of the authorization policy. Option 4 is that the PDP stores data. The PDP maintains a database of user attributes and synchronizes it periodically with the IDP. This option can lower the burden of PDP development and has low latency, but it raises the complexity of the system configuration. This table shows a summary of the 4 options. You should choose the appropriate method depending on your authorization use case. If you can tolerate the added complexity of your system configuration, option 4 is the recommended option in terms of authorization functionality. Finally, I will show you a demo using Keycloak and Topaz. First, I briefly introduce Keycloak. Keycloak is an identity and access management OSS, and it provides OAuth 2.0 authorization server features and single sign-on features. Keycloak is a CNCF incubating project. Keycloak's major features are: first, it supports standards such as OAuth 2.0, OpenID Connect 1.0, SAML v2, and so on. Second, Keycloak can log in with social networking services such as GitHub, X, Facebook, and so on. Finally, Keycloak can connect to existing user stores such as LDAP, Active Directory, and so on. Next, I briefly introduce Topaz. Topaz is an authorization OSS, and it provides fine-grained, real-time, policy-based access control for applications and APIs. Topaz's major features are: first, it supports AuthZEN authorization API endpoints natively. Second, Topaz can implement flexible authorization methods such as RBAC, ABAC, RBAC, and so on. Finally, Topaz can provide extensive developer resources such as Node.js, Go, Python, Java, ASP.NET, Ruby, and so on. I use Keycloak and Topaz for this demo, Keycloak for IDP and Topaz for PDP, and NGX as PEP. And I realize this option 4, the PDP stores data. The key point is how to integrate authentication and authorization data. First, we use a CLI tool called DSLoad to load Keycloak data into the authorization database included in Topaz. DSLoad is published on GitHub, and we prepared the DSLoad for Keycloak for this day, thanks to God for his help. And next, continuous data synchronization is performed following the scheme protocol. Keycloak is still currently developing a feature that supports scheme, but it will be supported in the near future. And this time, we used scheme for Keycloak and the Assalto scheme service. Both are also published on GitHub. So let's go to the demo. These are all ports of this demo. NGX for PDP, and Keycloak for IDP, and Topaz for PDP. I will show you first the NGX configuration. We implement the members API and this one, and we implement authorization for this API, and we implement this delegate authorization functions. And this function uses the access evaluation API I described before. This is the implementation of delegate authorization function. This function implements the access evaluation API, so the request body includes subject, resource, action, parameter. Also, we implement a logging feature this is to easily show you that interaction between PDP and PDP. And next, I will show you the authentication data in Keycloak. There are 2 users and 2 groups. And in admin group, there is test user, and in user group, there is test user 2. And this is the authorization data in Topaz directory. There is, for now, no users and no group. So, we use DS loads to load Keycloak data into Topaz directory. This is the command for DS load for Keycloak. And when execute this command, we can import 2 users like this, and also 2 groups, and also a relationship between users and groups are imported. And we already configured the members resource. This is corresponding to the NGX resource members API. And let's configure the relationship between resource and users. This can be done by GUI. And the relationship is like this. If the user belongs to admin group, then the user can read members resource. So let's call members resource. To call API, first we need to issue an access token following the OWASP 2.0 authorization code grant. And first, we log in with test user. Test user belongs to the admin group. So we can get the authorization code. And we exchange the authorization code to an access token. Then we use this access token to call API. The API call was successful. This is because test user belongs to admin group. I will show you the NGX log. And this is the request body of the access evaluation API. So it includes subject and resource and action parameter. Also, this is response body, and this response body includes decision true. So the API call was successful. Next, I will log in with test user 2. Test user 2 doesn't belong to admin group. Again, I exchange authorization code to an access token. then use this access token to core API. This time, 403 forbidden is returned. This is because test user 2 doesn't belong to the admin group. This is a request body in NGX log. And the response body says decision false. So next, we'd like to change the test user 2's group. So we added test user 2 to admin group. So test user 2 belongs both group admin and user. Then call API with the same access token. This time, API call was successful. And NGX log says the request body is the same as before, but the response body was changed to false to true. What happened? I only changed authentication data in Keycloak, and I didn't change authorization data in Topaz. But authorization decision was changed from false to true. That is, the synchronization was performed according to following the scheme protocol. This is the assert scheme service. This service received the scheme request and stored the authorization data into Topaz directory. So in Topaz, there's the authorization data that test user 2 belongs to admin group. And this is the scheme for Keycloak, and this service triggered the changing group membership event and then send scheme request to the Topaz. So the synchronization was successful, then the API call was successful. Yeah, this is the configuration of scheme for Keycloak. Yeah, demonstration was finished. So this is the summary of the session, and I hope this session helps you implement authorization. That's all. Thank you. Any questions?
Appreciated your great presentation and the demo. And two questions here. One is if the both an IDP authentication server and the authorization server has kind of no shared trust, no shared data, like using the ultra global IDP like Microsoft Enter ID, or even the IDP which is managed by the other department or other companies, or even the ID as a services. Which option can we take to share the information? This is the first question.
I see. So I'd like to answer the one by one. And your question is if the ID was managed by the either kind of Enter ID or something like that, and then which option can be adapted, yes. Right? Maybe just a moment. Maybe this option can be adapted. This is because the PDP manages their own database. So if the IDers, or this time use the Keycloak, but if the IDers support the scheme protocol, we can synchronize the authentication data and authorization data. So maybe this option can be adapted. And maybe the IDers supports some APIs querying the user data. This retrieve option can be adapted. Then, so that this option 2 also retrieve the user data from IDers or identity provider, so this can be adapted. I wonder, this depends on IDP, I think, because to adapt this option, identity provider can insert a user attribute that PDP can want. So if the identity provider, if we can customize the access token of the identity provider, yeah, we can adapt this option. But if we cannot insert the user attribute we want to the access token, we cannot adapt this option. So maybe this option is not clear we can adapt. But option 2, 3, 4, maybe we can adapt that kind of use case.
Got it, understand. Thank you. And quickly, the second one is if this standardization spec will be applied not only for the other protocols of the HTTP REST, like GraphQL, gRPC, or maybe the purpose or layer is different, but such kind of entry or even the model context protocol or other things.
Which interaction you mentioned?
Authorization flow, like maybe a number 2 and number 3.
Okay, this protocol.
Yep.
Currently, the OauthZEN, assumed that this interaction between PEP and PDP is a REST API. So, yeah, I don't know the plan for support GraphQL or kind of other protocol. Yeah, but currently the REST API is only supported. I understand. Yeah.
Got it. Thank you so much.
Thank you very much. Finished. Okay, so thank you for listening. And if you have any questions, yeah, I will hear at your time. So yeah, please ask me later. Thank you very much.